Hello, welcome to By Excellence Tutorials. We have a question here that we need to solve, and it's from circular motion. So the question reads, a 1,000 kilogram car rounds a cave on a flat road of radius 50 meter at a speed of 50 kilometer per hour, which is equivalent to 14 meters per second. Will the car follow the cave or it will skid? Assume A, the pavement is dry and the coefficient of static friction is 0.6, and B, we assume that the pavement is wet and the coefficient of static friction is 0.25. Okay, so we first try to assume that this is a curve, maybe a rod, and there is that, and then we have that as our car. Okay, so we have that as a car, and we have that as radius. So at that speed, is the car going to follow the cave, or is going to skid if the pavement is dry or if it is wet? Okay, so what we have to do now is to draw the free body diagram of the car and the forces that are acting in that car, on this car. So if we say this is the car, and it's just a free body diagram, we know that it's going to have the friction force. Okay, it's going to have the friction force or static friction force in that direction towards the center, and then it's going to have the normal force. Apart from the normal force, it's going to have the weight, which is mg. Okay, so that is the free body diagram of this car. So this car will follow the curve. We only follow the curve if the maximum static friction force is bigger. Okay, if it's bigger or greater than the net horizontal force that is needed or that is required to keep this car in a circular motion or to round the cave. Okay, so we first calculate the normal force, because for us to be able to know the maximum static friction force, we need to be able to know what the normal force is. So according to Newton's second law of motion, we have the summation of forces in the y, and there is no motion in the y. In the vertical, there is no motion. So of ma, which is equal to 0. And the forces that are acting in the vertical, we only have the normal force and the weight of the car. So we have normal force minus weight of the car being equal to 0. And then normal force equal to weight of the car, of which this weight of the car, we've been told to say the mass is 1,000 kg. And we take our gravitational acceleration to be 9.81 meter per square second. So our normal force of this car is going to be 9,810 Newton. So that will be the normal force of this car. Now we have to calculate as well the net horizontal force that is required. Mind you, I said the car will only follow the curve only follow the curve if the maximum static friction force is greater or bigger than the horizontal net force. So this horizontal net force is the force that is required to keep this car in a circular motion or in a curve or in a circle, okay, around the curve. So this net horizontal force is going to be that way, of which we know that this acceleration that we are having in this equation is the centripetal acceleration, of which this centripetal acceleration is given by linear velocity, square of the linear velocity times the radius, divide by the radius. So we have that, and then we can be able to calculate where we have 1000 kg mass multiplying by the speed we've been told is 14 meters per second. So we square and divide by the radius, and the radius is 50 meters. Okay, so we punch on the calculator, and what we are going to have now is this net horizontal force is going to be 3,920 Newton. So this is the force that is required to keep this car moving in a circle around the curve. Now, we need to calculate now the maximum total friction force to see if it's big enough, it's large enough to provide the safe centripetal acceleration. Okay, so we know the relationship between the friction force maximum, of course, is given by the coefficient of static friction multiplied by the normal force. So now we are on a where we assume that this pavement is dry and the coefficient of static friction is 0.6. So we have 0.6 multiplying by the normal force we calculated, 9,810 Newton. And then that is going to give us 5,886 Newton. So when you look at this maximum friction force, you are going to see that it's bigger than the horizontal net force that is required. And then this tells us to say this car is going to follow the curve. Okay, this car is going to follow the curve when the pavement is dry and the static friction coefficient is 0.6, because the maximum total friction force is bigger than the net horizontal force. Okay, so we get to be where the pavement is assumed to be wet, so the pavement is assumed to be wet, and then we do the same to get the maximum friction, static friction coefficient. Oh no, we calculate the maximum total static friction force. So we have 0.25 and multiplying by 9,810 Newton. And this is going to give us 2,453 Newton. So you can see this time around that when the pavement is assumed to be wet, the maximum total static friction force is smaller than the required net horizontal force. Thereby, this car is going to skid, definitely. Yeah. So that is how we solve that question. So subscribe to the YouTube channel for more of these videos.